Good evening. Good evening. Sorry, there was an issue in the Zoom. That's why I got a bit late. Okay, that's Sarah. That's Sarah. We need a party before you do your local O levels. You have got Cambridge A level results. Congratulations, right? Mari. Can you all turn on the videos? So still I couldn't fulfill one of the promises. I didn't send that unit 10 printed, not printed, the tute after typesetting, right? I told you that I will send it soon, right? These days I was a bit busy. Then today I thought of starting that electrochemistry lesson because we are having a session today and tomorrow in the morning. Therefore, we can, yes, most probably we will be able to finish Unit 12, electrochemistry part. Right? There is no tute for that. We will have to write. For Unit 14 also there is no tute, 12 and 14. For the others, I will share the tutes as usual. Hari. So shall we start? For Tavindra, Sheneli, Tarundi, can you turn on the videos? So we'll put the topic Unit 12, electrochemistry. So marks එක හම්බුණාද? සමහර අය නම් එව්වා. Just send me to the chat if you have received your term test marks. Most of you may haven't got yet, ne? After the holidays you will get. You had the term tests until the last moment, ne? So Vidula, Sheneli and Tavindra, turn on the video. Hari. So in this electrochemistry, if you can remember in grade 8 also you have learned about the relationship in between electricity and a chemical change, right? So here in an electrochemical cell, we experience the generation of electricity due to a chemical change, right? In electrochemical cells, okay, the simple voltaic cell, the lime fruit cell, the dry cells, in those due to chemical change electricity is generated, right? So in electrochemistry we are basically learning about these electrochemical cells as the first part of the lesson. Then the other half is based on electrolysis, right? That's very easy. You just understand the theory, then you will be able to answer the questions easily. හරිද? අමාරු දෙයක් නැහැ. අර බේසික්ස් ටික හරියට දැනගන්න. එච්චරයි. Okay. So if we move on now in you are familiar with the terms electrolyte, then the electrodes, right? You are familiar with those terms, but we will define them once again. Hari. So we don't need to write, there are so many electrical equipment that are powered by these cells. Now if you look around, even the laptop or the mobile phone that you are using, these are also powered by rechargeable cells, right? Then the remote controllers, they are powered by dry cells of different types, right? Tamanada, the torches, yes, what else? The calculators, even the watch that you are wearing, the clocks, these are powered by different types of cells, right? So we are going to learn the theory behind, especially first of all we will learn about the simple cell, right? Hari. අපි ඒ ටික ලියන්න ඕනේ නැහැ නේ equipment වල නම් ටික නේද? We will directly start with the first subtopic. Reactions occurring in electrochemical cells. Reactions occurring in electrochemical cells. Electrochemical cells. තව දින කීයද කියලා ලියන්න පුළුවන් නේ? Since you know the exact date. ලියනවානේ ඉස්කෝලේ ඉස්සර නම් ලියනවා. We had the blackboards නේ when we were schooling. දැනුත් ලියනවා මං හිතන්නේ. තව දින මෙච්චරයි කියලා ඔන්න ලියනවා. 250යි. ඊට පස්සේ ඊළඟ දවසේ තව එකක් අඩු කරලා 249යි. ඔහොමම අඩු කර කර ලියාගෙන යනවා. තව දින 1යි වෙනකම්. බැලුවද තව දින කීයද කියලා? 17th of February, right? ගණන් කරලා බලන්න දිදුල ඉන්න වෙලාවක ඔය. හරි. So we'll move on to activity 1. Hari. There you are provided with a dilute sulfuric acid solution and a zinc strip immersed in it. Dilute sulfuric acid, and this is the zinc strip or zinc sheet immersed in it. So what are the observations that you make here? Yes, since you have learnt this earlier, the reactions of metals with dilute acids. What are the observations? Yes. Yes, Tejan. Yes. Tatsara? Can't hear Tatsara. The metal starts to deteriorate means the metal dissolves, zinc strip dissolves, and you can see the evolving of gas bubbles. The gas is hydrogen, right? Hydrogen gas is evolved. So our observations are evolving of gas bubbles and the zinc strip dissolves. Liana observations ටික ඉස්සෙල්ලා ලියලෙමු. Observations. Gas bubbles evolve near the zinc strip. Gas bubbles evolve near the zinc strip. Then the other one is the zinc strip gradually dissolves. Zinc strip gradually dissolves. Hari. Now, if I ask you to write the reaction in between the zinc strip and the dilute sulfuric acid, you will write it now. Right? So we will learn what happens inside. Then අපි එක සැරේම reaction එක ලියන්න පුරුදු වෙලා හිටියේ. We'll see what is happening actually inside. So we call these as half reactions, right? Half reactions. Half reactions. We'll write the first half reaction. So what happens here is actually zinc strip dissolves means it gets oxidized, right? Oxidized means the zinc strip removes electrons and get positively charged, right? Zinc becomes positively charged after removing electrons. Zinc, which is in the solid state, removes electrons and become positively charged like this. Zinc 2 plus ions are formed, right? So this now this is in the aqueous solution, right? This has been added to the aqueous solution. Therefore, we can put that this is in aqueous state by removing 2 electrons. Zinc forms zinc 2 plus ions by removing 2 electrons. I can write it as minus 2e on this side, but rather than that I wrote it like that. Harida, this is the first half reaction. So it is not essential to put the physical state, not essential to put the physical state in this lesson. අපි කලින් ඉගෙන ගත්තේ මොනවාද heat changes associated with chemical reactions there. The physical state is essential. මෙතන essential නෑ. It's better if you can write. Zinc forms zinc 2 plus ions by removing electrons. That is the first half reaction. So this happens when there is someone to accept those electrons, right? ඊට කලින් අපි බලමු what happens to sulfuric acid. Sulfuric acid, in the 7th unit you learned how acids dissociate in an aqueous medium. එතකොට ඒක උඩින් ලිව්වා නම් හරි. දැන් මම half reactions කියලා ලියාගත්තා මෙතන. කමක් නැහැ. මම මෙහෙම ලියන්නම්කෝ මෙතනින්ම ලියන්න. Sulfuric, it is not a half reaction. This is how sulfuric acid dissociates. කොහොමද වෙන්නේ? It dissociates into H plus ions and sulfate ions. H plus ions and sulfate ions. Right? If I balance the equation, I have to put 2 H plus ions. Right? Now, sulfuric acid has been dissociated into H plus ions and sulfate ions. Now, here you can see there are H plus ions. So, these H plus ions will get attracted towards the zinc strip. Why? There are electrons. The removed electrons are there. So, those H plus ions get attracted towards the zinc strip. Now, ඔයගොල්ලන්ට මෙතනින්ම ලියන්න පුළුවන්. මම ඒක වෙනම ලියන්නම්. ලියන්න මම වෙලාව දෙන්න. මෙන්න මෙතෙන්ට එන්න ඕන එක තමයි මෙතනින් ලියන්න. H plus ions get attracted towards the zinc strip as there are electrons. This is positively charged, electrons are negatively charged. Therefore, the H plus ions get attracted towards the zinc strip where there are electrons. Harida? ඊට පස්සේ we can write the second half reaction. So, these H plus ions will obtain those electrons. ඔන්න එතෙන්ට දුවගෙන ගිහිල්ලා මොකද කරන්නේ? Obtain those electrons. H plus ions obtain the electrons and get released as hydrogen gas, H2 gas, right? This is the second half reaction. So, if I balance the equation, I have to put 2 H plus ions to this side. 2 H plus 2 electrons, it is released as hydrogen gas, right? That is the second half reaction. Hari, මෙතන එනකම් පැහැදිලිද? Is that clear up to this? දැන් අර අපි එක සැරෙන් ලියපු reaction එක දැන් මේ මොකක්ද වෙන්නේ කියලා බලනවා. Right? And if I repeat, zinc, since this is a metal, it tries to form positive ions. We call it as an oxidation. Removal of electrons is known as oxidation. Zinc removes 2 electrons and forms zinc 2 plus ions. Sulfuric acid in an aqueous medium gets dissociated into hydrogen ions and sulfate ions. Right? Hari. Then the hydrogen ions get attracted towards the zinc strip where there are electrons, right? Then these hydrogen ions obtain the electrons and get released as hydrogen gas near the zinc strip. That is what we observe as the evolving of gas bubbles. So that is known as the second half reaction. Why do we call them as half reactions? Then අපි ලියන reactions වල plus minus කියලා නෑනේ. We write the complete formula. We don't write ions or radicals there, right? That is why we call these as half reactions. හරිනේ? අර්ධ ප්‍රතික්‍රියා කියලා කියනවා in Sinhala. Okay. And take them down up to this. Okay, finished. Now I am going to erase because I need space. I can move to the next page. ඉවරයිනේ? හරි. So I will rewrite the two half reactions since I need to show them to you. The first half reaction I wrote, zinc forms zinc 2 plus ions after removing electrons. After removing electrons, this is the first half reaction. And the second half reaction is, you don't need to rewrite. Second half reaction is hydrogen ions obtaining electrons. Two hydrogen ions obtain two electrons and get released as hydrogen gas. This is the second half reaction. Then what I need to do is, I have to get the sum of these two reactions, two half reactions, 1 plus 2, right? So when you are adding those two reactions together, I have to write the things on my left hand side on the left hand side and things on the right hand side on the right hand side. Right? So I will write zinc plus 2H plus aqueous plus 2 electrons. Everything on my left hand side are written here. Then things on my right hand side, zinc 2 plus aqueous plus 2 electrons plus hydrogen gas. Then balan, this is like an equation. So on either side I have 2 electrons. So they will get deleted. Then what shall I write after that? So if we look at this equation, here we can see there are H plus ions. From where did the H plus ions come? H plus ions. Yes? From the dissociation of sulfuric acid. Therefore, I can add sulfate ions to the reaction. So now in the reaction there sulfate is not mentioned. Means sulfate kotanakaවත් ලියවිලා නැහැ. That means sulfate has not undergone any change. It has not participated in the chemical reaction. Sulfate participate වෙලා නැහැ. ඒක නෑව include වෙලා නැත්තේ. හරි. ඒ නිසා මම මෙතන ලියනවා sulfate ions have not participated in the reaction. Therefore, I can add sulfate ions to complete the reaction. මට ඕනේ reaction එක complete කරගන්න. Therefore, I will add sulfate ions to the reaction. So, if I do something to one side of the reaction, I have to do it to the other side as well. ඒ නිසා add sulfate to either side. දෙපැත්තටම add කරනවා sulfate. වෙනසක් නොවෙන්න. Not to make any change to either side. Right? So I can write zinc plus 2H plus sulfate. මේ පැත්තට sulfate add කළාම. To the other side also I have to add sulfate. Zn2 plus aqueous plus sulfate. Since I have added it to either side, I don't make any change in the reaction. Then බලන්න ඔයගොල්ලන්ට හුරු පුරුදු reaction එක එනවා නේද? මේ H plus and sulfate, they collectively form sulfuric acid, H2SO4, right? ඊළඟට මෙතන zinc is there. Zinc solid plus H2SO4. On this side, zinc ions and sulfate ions. That is zinc sulfate, ZnSO4 aqueous plus hydrogen gas. හරිද? අර ඕගොල්ලන්ට එක සැරේම ලියා ගන්න පුළුවන් equation එක දැන් තමයි අපි ගත්තේ. Right? So this is what is happening actually. Though we were able to write this reaction at the very beginning, this is actually what is happening. Right? You can take this down. පොඩක් තනියෙන් ලියන්න try එකක් දෙන්න. හරිද? Hari. Keep your videos on and do the work. If you don't understand anything, just let me know. Hari. Done. So now what has happened is there is an exchange of electrons in between zinc and hydrogen ions. Ne? Zinc removed electrons, hydrogen ions obtained those electrons. They have exchanged the electrons. Right? Electron exchange එකක් තමයි කරගෙන තියෙන්නේ. So if we can connect this by using an external conductor, these electrons will flow through the conductor. Right? An electron current flowing through a conductor is known as an electric current. So we can generate an electric current if we connect these by using an external conductor. That is what we do in a simple cell. Hari. If you have finished writing, can you write like this? If the exchange of electrons, if the exchange of electrons in between zinc metal and hydrogen ions, if the exchange of electrons in between zinc metal and hydrogen ions, zinc metal and hydrogen ions occur through an external conductor, occur through an external conductor, an electric current can be produced. An electric current can be produced. An electric current can be produced. Ari. Then we'll move on to activity 2. Right, now we are going to connect them through an external conductor. A zinc sheet and a copper sheet are taken. Hari. Activity 2. We'll draw here. Zinc and copper. These two are connected by an external conductor, and we can connect an ammeter or a center zero galvanometer as well. Right? Hari. So here this is the zinc strip and copper strip. This is dilute sulfuric acid. Right? Then you can write down the observations as usual. What are the observations? Observations. What are the observations? Another than dakinne. Yes. The simple cell that you have learnt in grade 6 also. Yes. Another dakinne. Yes. Yes, Nelly. Emitter shows a deflection, right? Then as usual, the zinc strip dissolves and gas bubbles get accumulated near the copper strip. Right? The copper strip is covered by gas bubbles. Right? Hari. Liyamu observations liyanako yala. The ammeter shows a deflection. Ammeter shows a deflection. Then the zinc strip dissolves. Zinc strip dissolves. Then gas bubbles get accumulated near the copper strip. Gas bubbles get accumulated near the copper strip. Hari. Then we can rewrite how sulfuric acid is dissociated. Sulfuric acid gets dissociated as H plus ions and sulfate ions. Right? H plus ions and sulfate ions. If I balance, I have to write 2 H plus ions. Right? Now in the solution, there are H plus ions, sulfate ions, since there is water, there is hydroxyl ions as well. Hari. Then අපි බලමු මොකද වෙන්නේ කියලා. We will write the half reactions. I will say at the zinc strip. At the zinc strip, what happens? Zinc removes electrons and form positive ions. Right? By removing electrons. This is the first half reaction. Hari, the first half reaction. Now there are electrons there. So these electrons move towards these electrons. Now here there are electrons near the zinc strip. These electrons move along the external conductor. Electrons move along the external conductor towards the copper strip. හරිද? දැන් conductor එකක් තියෙනවානේ. ඒක දිගේ ගලාගෙන යන electrons ටික towards the copper strip. හරි. So we can say these electrons move towards the copper strip through the external conductor. Through the external conductor. Hari. Now in the medium, who are there? In the medium, there is H plus ions and sulfate ions both. Hari. Now, since electrons are coming near the copper strip, H plus ions get attracted towards the copper strip. H plus ions tika dula yana copper strip එක ළඟට, since there are electrons. And we can write the second half reaction at the copper strip. At the copper strip. What happens? These H plus ions obtain those electrons and get released as hydrogen gas. This is the second half reaction. Second half reaction. So if I balance the equation, I can put 2 H plus ions. Since the charge is plus 2, in order to balance it, I put 2 electrons. So on this side, the overall charge is 0. On this side also plus 2 and minus 2. The overall charge is 0. That is why I have put 2 electrons. So these are the two half reactions. Done? Hari. Then hari neda. Now we call the removal of electrons as oxidation. Therefore, this first reaction is known as the oxidation half reaction. Right? Removal of electrons is known as oxidation. Therefore, the first half reaction is known as the oxidation half reaction. And you know, this zinc and copper are known as electrodes. The electrode where oxidation takes place is known as the anode. Therefore, here zinc is known as the anode, right? තව දෙයක්. Since there are electrons on the zinc strip, it is negatively charged relative to the copper strip. Therefore, zinc becomes the negative electrode. Negative electrode is the anode in an electrochemical cell. Electrolysis වලදී ඕක අනිත් පැත්ත ගන්නවා. Right? The opposite. So, and I will repeat. Removal of electrons is known as oxidation. The electrode where oxidation takes place is the anode. Therefore, zinc becomes the anode. This is the oxidation half reaction. Since there are electrons on the zinc sheet, it is relatively negatively charged when compared to copper. Therefore, zinc becomes the negative electrode. හරිද? හරිනේ? ටික ටික දාගන්න ඕනේ ඉතින් ඔළුවට. අමාරු නෑනේ. අපි එකින් එක ගත්තේ. එතකොට half reaction. What is the reaction happening near the zinc strip? එතකොට එතෙන්දී අපි දන්නවා zinc is more reactive than copper. Therefore, it will be oxidized. It will remove electrons. You know, copper does not react with dilute acids. Neither. Grade 10 knowledge. Therefore, zinc gets oxidized. Then the electrons move along the external conductor towards the copper strip. Ek balagena hitiya hydrogen in the medium. Then it ran towards the copper strip and obtained electrons and got released as hydrogen gas. Harida? Now, අපි ඉස්සෙල්ලම පළවෙනි එක ලියමු about oxidation. And you can use a different color or whatever. Write down this as point-wise. Removal of electrons. Removal of electrons is known as oxidation. Removal of electrons is known as oxidation. Oxidation. Electrode where oxidation takes place. Electrode where oxidation takes place is known as the anode. Is known as the anode. Within brackets put zinc. Zinc is the anode. The first half reaction is the oxidation half reaction. The first half reaction is the oxidation half reaction. The first half reaction is the oxidation half reaction. As there are electrons, zinc is the negative terminal. Zinc is the negative terminal. හරි. ඊළඟට මේ gaining electrons, hydrogen gained electrons. Gaining electrons is known as reduction, right? reduction. Therefore, this is the reduction half reaction. So, it happened near the copper strip. And the electrode where reduction takes place is known as the cathode. Here, copper is the cathode, right? And it is the positive terminal of this cell. Positive terminal of the cell. The gaining electrons is known as reduction. The electrode where reduction takes place is the cathode. Here copper is the cathode, right? And copper is the positive terminal of this electrochemical cell, right? Cathode is the positive terminal in an electrochemical cell. හරිද? එකත් වෙනවා color එකකින්. ඊළඟට ලියන්න leave a line and write. Gaining of electrons is known as reduction. Gaining of electrons is known as reduction. The electrode where reduction takes place, the electrode where reduction takes place, the electrode where reduction takes place, the electrode where reduction takes place is called the cathode. The second half reaction, the second half reaction is called the cathodic reaction. The second half reaction is called the cathodic reaction. Now, the copper becomes the positive terminal of this electrochemical cell. Copper becomes the positive terminal. Copper becomes the positive terminal of this electrochemical cell. Now write the overall cell reaction alone. 1 plus 2. 1 plus 2 is the overall cell reaction. Overall cell reaction. ලියන්න බලන්න තනියම. 1 plus 2. Write it alone. Sorry. So did you write the overall cell reaction? Zinc in solid state plus 2H plus aqueous. මම දැන් 2 electrons හිතෙන් අයින් කරලා ඔයගොල්ලෝ දෙපාරකට ලිව්වට කමක් නැහැ. Zinc 2 plus aqueous plus hydrogen gas. හරිනේ? Did you get like that? Yes. Then you can add sulfate to either side and rewrite the equation as we wrote earlier. Zinc plus H2SO4, zinc sulfate and hydrogen. හරි නේද? Then a setup used to generate electricity by a chemical reaction like this is known as an electrochemical cell. දැන් මේ chemical change එකක් නේද උනේ? Right? They have undergone chemical changes. As a result, flow of electrons take place through the external conductor. අපි electron flow එකනේ mark කළේ. You know the conventional current flows to the opposite direction of the flow of electrons. Therefore, the current flows from copper to zinc. Current flows from copper to zinc. හරිද? Electrons flow from zinc to copper. The conventional current flows from copper to zinc. එක හොයාගන්න විදිය අපි ඊට පස්සේ summary එකක් ලියමු. ඕන දෙයක් දුන්නොත් කොහොමද හොයාගන්නේ? From where to where does the current flow? From where to where do the electrons flow? Right? We will learn a summary after writing the definition for, not the definition, we will write about the electrochemical cell like this. Hari, a setup used to generate electricity. A setup used to generate electricity by a chemical reaction. By a chemical reaction is known as an electrochemical cell. Is known as an electrochemical cell. The next point, the liquid or the solution. The liquid or the solution which conducts electricity. The liquid or the solution which conducts electricity is known as the electrolyte. Is known as the electrolyte. Then next one. The conducting materials dipped in the electrolyte. The conducting materials dipped in the electrolyte conducting materials dipped in the electrolyte are called the electrodes. Are called the electrodes. Hari. Now we will summarize the things that we have learned related to electrochemical cells. බලන්න අපි මෙච්චරයි ඉගෙන ගත්තේ. The chemical reaction happened with zinc and dilute sulfuric acid. That was the first thing that we learned. හරිද? So turn on the videos. Elisha, Tinuli, Tejan, what happened? Hari. Then we learned the half reactions there. Then the reaction when zinc and copper strips are immersed in dilute sulfuric acid. Then we'll move on to the summary. That is, we'll say electrochemical cells. Electrochemical cells. Summary. ඔන්න ඔය summary එක මතක තියාගත්තාම හොඳටම ඇති. Then you can build up the equations. Hari. I will draw the cell. The two electrodes dipped in the electrolyte. This is the electrolyte, right? These two are connected by an external conductor. Hari. Then we learnt that out of zinc and copper, zinc was more reactive than copper. Ahenang, the metal above in the activity series, what happened? It removed electrons and undergo oxidation, right? I removes electrons and undergo oxidation. The metal above in the activity series undergoes oxidation. Harida. The electrode where oxidation takes place is the anode. Electrode where oxidation takes place is the anode. Anode is the negative terminal. ඔන්න ඔය ටික මතකයි දැන්. Negative terminal of the electrochemical cell, right? The metal above in the activity series undergoes oxidation. The electrode undergoing oxidation is the anode. It is the negative terminal. So I will say that this is the anode, right? This is the anode. It is the negative terminal of the electrochemical cell, right? Then the next point. The metal below in the activity series. The metal below in the activity series. Below in the activity series is the cathode. Below in the activity series is the cathode, right? Cathode. So reduction takes place near the cathode. So cathode is the positive terminal. The metal below in the activity series is the cathode. It undergoes reduction. The cathode is the positive terminal of the electrochemical cell. So I will say that this is the cathode, right? It is the positive terminal. Now, since there were electrons, the electrons move towards this direction. Electrons move from negative terminal to the positive terminal. electrons, right? And the conventional current flows to the opposite direction. Therefore, current flows from positive terminal to the negative terminal. I flows. The current flows from positive terminal to the negative terminal. හරි නේද? ඔච්චරයි. මතක තියාගන්න තියෙන්නේ. හරිද? ඔන්න ආයෙත් කියනවා නම් the metal above in the activity series undergoes oxidation. Again, removal of electrons. Right? So it becomes the anode. Anode is the negative terminal. Why? It removes electrons and there are electrons near the anode. These electrons move along the external conductor to the other metal. It is the metal below in the activity series. It gains electrons. That is known as reduction. The electrode where reduction takes place is the cathode. Cathode is the positive terminal of an electrochemical cell. You know, conventional current flows from positive terminal to the negative terminal. හරිනේ? එතකොට ඔය ටිකෙන් පුළුවන් නේද what is the direction of the flow of current, from where to where do the electrons flow? ඒවා කියන්න පුළුවන් නේ? You have to remember like that. හරි. නම් තව එකක් ඇඩ් කරගන්න පුළුවන් මේ මෙතන ලියපු එක. Electrons move from negative terminal to positive terminal. Positive terminal. ඊළඟට current flows from positive terminal to the negative terminal. Logical කිසි දෙයක් කටපාඩම් කරන්න නැහැ. Positive terminal to negative terminal. අද රෑ වෙනකන් ඉඳලා ආයි හෙට උදෙත් අද රෑ අපි අන්තිමට හම්බ වෙලා නිදාගෙන හෙට උදේ නැගිට්ටාම තාපහු ඉස්සෙල්ලාම හම්බ වෙන්න වෙනවා. 6 o'clock. අද paper class එක නම් මට half an hour early ඉවර කරන්න වෙනවා. ඒ half an hour මම හෙට කරන්නම්. There is a meeting at my son's school. Online meet. Okay, Tejan, I just saw your messages. Now do you understand? හරිද Tejan? ගේ ප්‍රශ්න ටික. Have you finished writing? No. Okay, shall we watch a video then? Okay, with that motivational story, I will give you two questions, right? With the knowledge that you have gained, you can write the answers. Yes, Didula. The electrode where reduction takes place is the cathode, no? So cathodic half reaction is the reduction half reaction. Both are the same. Right? Cathodic half reaction and the reduction half reaction, both are the same. Then anodic half reaction and the oxidation half reaction are the same. Harine? Okay, Tavindra. Hari. And I will give you the two questions. Uh, this is iron and this is copper. And they are immersed in dilute sulfuric acid solution. So you are supposed to do the, you are supposed to write the oxidation half reaction, then reduction half reaction, you have to write this. Overall cell reaction, what is the anode, what is the cathode, direction of the flow of electrons, direction of the conventional current, ටිකට උත්තර දෙන්න ඕන. Turn on your videos. Okay, finished. Hari. Then Hari. So have you finished? What is the oxidation half reaction? Then we can first find what is the anode and what is the cathode. Hari. Yes, what is the anode? Shanali, what's the anode here? Anode is the one. Yes. Yes, Shanali. The iron strip. So when we consider iron and copper, iron is above in the activity series. Then activity series එක මතක තියෙන්න ඕනේ. Iron is above in the activity series. Therefore, iron undergoes oxidation. So the electrode where oxidation takes place is the anode, right? Then copper is the cathode, right? So oxidation means the removal of electrons. Iron removes electrons and form plus 2 ions. We can say ferrous ions are formed. Iron also forms plus 2 ions, right? It forms plus 3 ions as well. But most stable is this and electrons. So this is the oxidation half reaction or the anodic half reaction. Then the reduction half reaction. Now you know sulfuric acid dissociates as H plus and sulfate ions. So these electrons, since there are electrons near iron, these electrons move along the external conductor. Electrons move along the external conductor to the copper strip. And direction of the flow of electrons is from iron to copper. Electrons flow from iron to copper. Now there are hydrogen ions in the medium. They get attracted towards the copper strip since the electrons are coming. So the reduction half reaction is H plus ions obtaining electrons getting released as hydrogen gas. Getting released as hydrogen gas. In order to balance this, I have to put 2 H plus and 2 electrons, right? That is the reduction half reaction or the cathodic half reaction. So to get the overall cell reaction, I can say iron plus 2H plus 2 electrons, and here also there are 2 electrons. Enisa, I can just write it like this. Fe2 plus Fe2 plus hydrogen gas. ඉතින් ඕකට අපිට sulfate add කරලා Fe plus H2SO4 ඊට පස්සේ FeSO4 plus H2 කියලා reaction එක ඉවර කරන්න පුළුවන්. එහෙම ලිව්වද? Fe plus H2SO4 FeSO4 plus H2. කො බලන්න එහෙම ලියපු අය? මට මෙතන ඉඩ නැති හින්දා අන්න මම පහලින් ලියන්නම්. මෙතන ලියන්න ඕන එක. So either side I add sulfate. So Fe plus 2H plus sulfate කියන්නේ H2SO4. H2SO4 equals, then to the other side also I have added sulfate. FeSO4 ferrous sulfate equals plus hydrogen gas. ඔක තමයි overall cell reaction. Did you write? ලියලා ගොඩක් අය. Good. ඊට පස්සේ direction of the conventional current. කොහෙටද? Yes. The electrons flow from iron to copper. Current flows from copper to iron. From copper to iron. from copper to iron. Hands up those who got all correct. Honestly. Yes. ඔක්කොම මේ විදිහට ලිව්වා නම් කො බලන්න. Yes, good. 2 of 3. 4. 5. Okay, very good. දිදුල වැරදුනවද? කවිනු? දිදුල මොකද උනේ? ඒ කියන්නේ you didn't write this one. මේක ලිව්වා. It's okay then. Hari, mega api sulfate does not take part in the reaction. Therefore, we add sulfate to either side. So, ions නැතුව අපි reaction එක ලියනවා. Right? That becomes the overall reaction. It's okay. Yes, Tedini? Okay, okay. Hari. තව එකක් දෙන්න. Zinc and iron. Zinc and iron. තනියෙන් ඇඳලා තනියම ලියන්න මේ ප්‍රශ්න ටිකට උත්තර. The two electrodes are zinc and iron. The electrolyte is dilute sulfuric acid. Hari. What did I give you? Iron and zinc, right? Zinc, iron, so you know sulfuric acid gets dissociated into H plus and sulfate ions. Then what is above in the activity series? Zinc or iron? Yes, that is Zinc. Zinc is above in the activity series. Therefore, it undergoes oxidation. It undergoes oxidation. So, the anode is zinc. The electrode where oxidation takes place is the anode. Anode is the negative terminal since electrons get accumulated due to the removal of electrons. Zinc removes electrons and forms zinc 2 plus ions, and the removed electrons are there. So this is the oxidation half reaction or the anodic half reaction. So the these electrons move along the external conductor towards the ion stream. There are H plus ions in the medium, so H plus gets attracted towards the ion stream. So since the anode is zinc, cathode is copper. It is the positive terminal. So reduction takes place near the cathode. Reduction takes place near the cathode. So the cathodic half reaction or the reduction half reaction is hydrogen ions obtaining those electrons. H plus obtain those electrons and get released as hydrogen gas, right? So to balance the equation, 2H plus, to balance the charges, I have to put 2 electrons. So this is the reduction half reaction or the cathodic half reaction. Then the overall cell reaction is overall cell reaction zinc 2H plus 2 electrons, zinc 2 plus 2 electrons plus H2 gas. 2 electrons, 2 electrons. To either side I add sulfate, zinc plus 2H plus sulfate, zinc 2 plus aqueous plus sulfate plus hydrogen gas. So it becomes zinc plus H2SO4, H2SO4 aqueous, zinc sulfate and hydrogen gas. Zinc sulfate and hydrogen gas. That is the overall cell reaction. Then puluwanne? That is all. Yes, Tejan? Oh, Tejan. සාමාන්‍යයෙන් එහෙම එන්නේ නැහැ. හරිද? දැන් zinc is 2 plus, copper 2 plus, iron 2 plus. ඔය ටික තමයි දෙන්නේ. අනිත් ඒවා within the first 20 elements you know about the metals. එතනින් එහාට එළියෙන් අහන්නේ නැහැ. දැන් in the electrochemical cells ඊළඟට electrolysis වලත් අර ඔයාලගේ textbook එකේ තියෙන examples වලින් පිට මෙච්චර කාලයකට අහලා නැහැ. ඉස්සරහටත් අහන්නේ නැහැ. ඒ නිසා don't worry. මේ අර summary එක මතක තියාගන්න. ඒකට අනුව දන්නේම නැති element එකක් දෙන්නේ නැහැ ඔයාලට. හරිද? ඒ නිසා summary එකයි ඒ theory එක මතක තියාගන්න. එතකොට කඩපාඩම් කරන්න ඕනෙත් නැහැ. electrolysis tomorrow I will give you a summary like that. Then you can remember the two summaries. That's all. Electrochemistry කියලා මහා ලොකු lesson එකක් නෙවෙයි තියෙන්නේ. If you have an idea about the activity series and how to write the chemical reactions, you can write those. පුළුවන්නේ? දැන් හරිද හැමෝගෙම ඔක්කොම ටික? So the electrons flow from zinc to iron and the conventional current flows from iron to zinc. හරිනේ? Conventional current flows from iron to zinc. ඔක බලන්න හරියයි ඔක්කොම? 1 2 3 4 5 6 7 හරි කවිනු වැරදුනාද කවිනු got disconnected I think හරි okay ඉතින් ඔය ටික තමයි related to the electrochemical cells that we have to discuss. So tomorrow morning we can start the electrolysis. After electrolysis මේ වගේ තමයි පොඩි දෙයක් තියෙන්නේ. ඊට පස්සේ ඒක ටිකක් examples වැඩි. Then we have to discuss about the rusting of iron. What are the chemical reactions happening place and how to protect iron from rusting. එතකොට මේට වඩා ටිකක් දිගයි ඒක කොටස. So දැන් ඒක පටන් ගත්තොත් මේක උඩටම ආපහු mix up වෙනවනේ නේද? Dekak, totally opposite. In electrochemical cells, the chemical change leads to an electric current. Chemical change generates an electric current in an electrochemical cell. In electrolysis, what happens? Due to the passage of an electric current, a chemical change occurs. The chemical change occurs due to the passage of an electric current. That is electrolysis. Totally opposite. හරිද? දැන් මම ඔයගොල්ලන්ට දැන් ලීව් වෙන්න පුළුවන්. ලීව් වෙන්න මම දැන් පැය භාගයක් තියෙනවානේ paper class එකට. I told that I will have to stop the paper class half an hour early today. එතකොට now I will share the question paper. You write I think there are 3 questions. You write answers for at least 2 questions and join at 7:30. paper class එක අඩු වෙන පැය භාගය අද අඩු වෙන පැය භාගය හෙට කරනවා හෙට 6 to 8:30 I have put the theory class in the morning and 9 to 11 the paper class then හරිනේ දැන් share කරන්න ඊළඟට තව දෙයක් then from by October I think we will be able to finish everything all the theory part. හරිද අපිට ඉතුරු වෙලා තියෙන electronics the 11th unit ඊට පස්සේ 12th කරනවා දැන් ඊට පස්සේ 13 electromagnetism and electromagnetic induction හරිද ඒකත් මේ වගේ totally opposite electromagnetism and electromagnetic induction ඊට පස්සේ තියෙනවා unit 14 hydrocarbons එක දවසින් ඉවරයි hydrocarbons ඊට පස්සේ 15 වල නම් සෑහෙන දේවල් තියෙනවා කතා කරන්න. ඒකට පුළුවන් තරම් නිවාඩුවක් ආපු ගමන් ක්ලාස් එකක් දාලා ඔක්තෝබර් වෙනකොට ඉවර කරගන්න තමයි ටාගට් කරන්නේ. ඒකට ඔක්තෝබර් මැද වුණාද අපි ඔක්තෝබර් අයින් කරමු නොවැම්බර් ඩිසෙම්බර් ජනවාරි. ඒකට 3 months totally questions. හරිද revision. හරිනේ? Okay. And then I will share the question paper in both theory class and paper class groups. You write the answers and join. So writing answers alone is something essential. හරිද කොච්චර theory ඉගෙන ගත්තත් ඔයගොල්ලෝ ප්‍රශ්න වලට තනියෙන් උත්තර ලියලා පුරුදු වෙන්නම ඕනේ. That is essential. We don't know what type of a question paper will come. ඒකට අර cricket practice කරනවා වගේ you have to bat as much as possible. පුළුවන් තරම් face කරන්න ඕනේ වගේ තමයි මෙතනත් you have to face a large number of questions then only you will get the practice හරි මම එවන්නම් ලියලා by 7:30 you have to join right okay bye see you tomorrow at 6 o'clock in the morning with the theory class right good night